Hello everyone, welcome to Answer YouTube channel. Today we will learn about shear force diagram and bending moment diagram. This topic is related to the subject of strength of material. It is highly useful for civil and mechanical branch. So let's try to understand how to draw shear force diagram and bending moment diagram with the help of an example. So here I have shown a beam in which there are two supports at B and D, and above this beam there is one UDL, uniformly distributing load of 2 kN per meter from A to C, spanning across 3 meter and 9 meter, and then there is a point load of 8 kilonewton acting downward. So first we will have to calculate what is the reaction force at B and D. So let's try to understand how to calculate this force using the formula. If a force of P kilonewton is acting somewhere on the beam having a span length of A plus B, and P is at A distance from left and B distance from right. So the left support will carry a load of PB upon A plus B, and the right support will carry a load of PA upon A plus B. So in the given question there are two loads, as we have discussed. From 3 meter to 9 meter we have UDL, and at 9 meter we have sudden of point load acting of 8 kilonewton. So if we forget that there is no UDL, we will get this kind of diagram, and for this 8 kilonewton we can calculate uh, load at B and D, and by the calculation we will get the force acting on, or the reaction acting at B is 2 kilonewton and the reaction acting at D is 6 kilonewton. So 8 into 3 by 12 is 2, and 8 into 9 by 12 is 6. And if we forget that there is no this point load and only UDL is acting, then total UDL load will be 12 multiplied by 2, that is 24 kilonewton. And if we change this UDL by a point load of 24 kilonewton only, and then this load will act at the middle point of this span of 12 meter, which is 6 meter from the left. So using the calculations and the figure diagram, we can easily say the load at B will be 24 multiplied by 9 by 12, and the load at D will be 24 multiplied by 3 by 12, which will give us 18 and 6. Now the overall reaction load at B and D can be calculated by adding 2 and 18, which is 20, and at D 6 plus 6, that is 12. So for the given loading diagram, the total reaction at B will be 20 kilonewton and the total reaction at D will be 12 kilonewton. So once we have calculated the support reactions, we can draw shear force diagram and bending moment diagram. Now to draw a shear force diagram, we should keep in mind that dV by dx is equal to W, and to draw the bending moment diagram, we should keep in mind that dm by dx is equal to V. That means loading is equal to rate of change of shear force, and shear force is equal to rate of change of bending moment. So basically the slope of bending moment diagram will be calculated using shear force, and the slope of shear force diagram will be calculated using the loading. So we will start from left and move to the right. So as we start from point A, so on the left of point A there is no loading, so the shear force will start from 0, and since the load is UDL, and the 2 kilonewton per meter will keep on increasing, and it will reach its highest value at B, between A and B, that is 2 into 3 of 6 kilonewton, and this is negative and increasing. So from A to B there is a straight line curve with slope of 2 minus 2, and at B there will be a sudden jump of 20, so minus 6 plus 20 will give us 14, and again from B to C there is load increasing and negative. Okay, so after getting 14, the load will getting reduced by the term of 2 into 9, which is 14 minus 18, that will be equal to minus 4. So between 14 and minus 4, there is a point somewhere between B and C where the CF force will get to 0, and we can calculate that value by using similar triangles. So from here to here it is 8 and it is 4. This is similar triangle using double similarity. So 8 upon, let us say this is x, and this is 4 upon 9 minus x. So if we cross multiply, we will get 4x is equal to 72 minus 8x, or 12x is equal to 72. Uh, so x and 9 minus x. Okay, so 8 and 4, 4x is equal to 72, 72 minus 8x. So and by solving this similarity, we can get x is equal to 7 meter. Okay, so we can easily calculate this value of x, so by solving that 14 minus 0 upon 2 is equal to 7 meter from B. Okay, and at B there will be a sudden drop of 8 Newton, 8 kilonewton. So from minus 4 we will get to minus 12, and since there is no loading between C to D, this minus 12 will become constant till D, and at D there is a sudden increase of 12 kilonewton. So at D the shear force will finally become 0. Now using this shear force diagram, we will try to calculate this bending moment diagram. So as I have already told you, the shear force diagram will give us the slope of bending moment. Now between A to B, the shear force is negative and increasing. That means the slope of bending moment diagram will be negative and increasing. So for a straight line, it will become parabola between A to B, and from B to C, the bending moment diagram will again become the bending moment diagram slope again is decreasing. Okay, the slope uh, can be calculated using this shear force diagram, and the bending moment at various points can be calculated like this, that such as bending moment at point B can be calculated by using the area of this triangle, half into 6 into 2. This will give us 6. Half into 6 into 3, that will give us 9 kilonewton meter. Okay, and when the bending moment uh, change from negative to positive, at somewhere it will become 0. That point is known as point of contraflexure. We will calculate the value of that point of contraflexure later in this video. So we have to keep in mind that bending moment is negative and increasing, so the curve will be parabola. And between C to D, there, since there is no loading, bending moment is horizontal. So the bending moment, since shear force is horizontal, bending moment will be linear. So we have to keep in mind between A to B, it is a parabola. From B to C, it is a parabola. But between C to D, it is a linear. At last, we can draw the deflected shape of the uh, loading diagram. So between A and E till point of contraflexion, the beam will give hogging moment, and between E to D, the beam will give us sagging moment. So we have explained the calculation for shear force diagram and bending moment diagram in the in a detailed manner after this diagram. So between A and B, at B, between B and C, and at C, between C and D, it is calculated like this. And similarly for bending moment diagram also we have calculated starting from A, then A to B, at B, and between B to F, and then mm, F to C, and then C to D, and at D. And for counterflexure we have calculated uh, point value of distance x like this, using this triangular diagram of shear force diagram, uh, using this section of trapezium. We have calculated the value of x, since area of trapezium is equal to half into sum of parallel sides plus distance between them. Okay, so here one side is 14, other side can be calculated by a similar triangle, and we will get as 14 minus 2x. And by solving this and cross multiplying each other, we will get a quadratic equation. And by solving the standard formula of b square minus b plus minus under root b square minus 4ac upon 2a, we will get a value of x as 0.675 meter. So this is how you can calculate point of counterflexure value, and this is how we have drawn shear force diagram and bending moment diagram for the given loading. Thank you for watching this video and have a nice day.